We are looking at section 4.5, part 2, and this says that if we have this function written this way, and it has integer coefficients, then every rational solution of the function, if we let it equal 0, is going to have the following form. It's always going to be P over Q. P is going to be the factor of this constant term. Q is going to be all the factors of the leading coefficient right there. So this is saying to find the possible rational roots for this function. So I'm going to look at all the p-values. P is going to be all the factors of 12. The factors of 12 are going to be plus or minus 1, 2, 3, 4, 6, and 12. All that means is that those are the numbers that 12 can be divided by evenly. Now I'm going to look at all the factors of 3. Factors of 3 are just going to be 1 and 3. So if I want to find the possible rational roots, it's going to be all of the p values divided by any of the q values. So my possible rational roots, and the word rational just means fractional, I have to do all the combinations. So it's going to be plus or minus any of the following. 1 divided by 1, 1 divided by 3. 2 divided by 1, 2 divided by 3. 3 divided by 1, and then 3 divided by 3 is 1, which I already did. I'm not going to do it again. 4 divided by 1, and 4 divided by 3. 6 divided by 1, 6 divided by 3 is 2, I already did it. 12 divided by 1, 12 divided by 3, I already did it. So we can have plus or minus any of these to be our possible rational roots. Now, does that mean they are the rational roots? Well, no. If I want to see what those rational roots are, the fastest way is just to put it into my calculator. And I could look at where is it that this function equals 0. But we're not going to do it that way because we could actually do this by factoring. We could just use grouping. Okay, we're not going to do it, but realize that any answers we get should be one of these right here. Now it's asking us to find all the zeros for this function. I'm first of all going to look at what my rational roots possibilities would be. So it's going to be plus or minus all my factors of the last term are going to be 1, 2, 3, what else? 5, 6, 10, 15, and 30. Those are all the factors of that. Then I'm going to look at the factors of my first term, just 1. So my only possible roots are going to be plus or minus any of these values. If I plug in one of these values and I get 0, that means it's going to be a 0. It causes the function to equal 0. If I plug in 1, would 1 give me 0? No. So I can get rid of the 1. But maybe negative 1 is a 0. See, I can't do this any other way except the way that I'm doing it, and that is to find one of the zeros by looking at the possibilities. So I have 1, 6, negative 1, negative 30. I've got negative 1, that's 5, negative 5, that's negative 6, that's 6, that's not going to work, is it? So now I might want to try something else, and maybe I want to try 2. And as soon as you see something won't work, stop. So that's going to be 2, that's 8, that's 16, that's 15, that's 30, that worked, didn't it? So that means that x equals 2 is one of my zeros. Look at what I have left. This is the constant term, this is the x term, this is the x squared term. So now I've got x squared plus 8x plus 15. I want to solve that for equaling 0. What are numbers that multiply to be 15 and add to be 8? What are they, guys? 5 and 3. So So this is going to factor down into x plus 5 and x plus 3. So my solutions are going to be negative 5 and negative 3. So all of my x's then, all of my zeros, I'm going to write it here where I have room, are going to be 2, negative 5, and negative 3. I check my degree, it's 3. I'm supposed to have 3 solutions, and I do. And so that's how we solve that.
But, wait, I just lost track after the x, before the x squared thing, so how did that come up? Oh, you factored out with that, okay.
Alright, so then these are going to be the zeros. Now, if I wasn't sure that I was correct, I could always check it on the calculator. I could go to my calculator and type this in. You don't need to do this, I just want to show you. So I should be seeing zeros at negative 5, negative 3, and 2, and I do. I can also look at my table, and I should see at 2 I've got a 0. At negative 5 we have a 0, and at negative 3 we have a 0. So I can check it that way. Now, I want you to look at the relationship between these zeros and this equation. What's the relationship between negative 5 and negative 3 and this number? This number is the what, Allison? Right. These two multiplied would give me the 15, right? What else? What would I do to these to get that number? I could add them, but then do what? Change the sign, right? What do I get if I add these two? And then change the sign. 8. This is a pattern that will always work. Look at this. What if I give you zeros of 4 and negative 5? The equation is going to go x squared. I find the sum of these two. The sum of these two is negative 1, and the product of these two is negative 20. Back here, what did I do with the sum when I put it in front of the x? Change the sign. So this is going to be x squared plus 1x. With the product, did I have to change the sign? No. Minus 20. So this function right here should be the one that would give us zeros of 4 and negative 5. Now, here's another way I could have done it. If 4 is a 0, it would have been x minus 4. If negative 5 is a 0, it would have been x plus 5. If I multiply this out, I'm going to get x squared plus 5x minus 4x minus 20. And that would give me x squared plus x minus 20. See how I get the same answer doing it that way? So this is a very, very helpful rule to know. And we're going to write it down on the next page. Given zeros of A and B, the function with those zeros is f of x equals x squared minus the sum x plus the product. So in other words, if I know the sum of the two zeros, that's going to be the coefficient of x, and I always have to change the sign on that. If I can find the product of those zeros, that's what's going to go here at the end for my constant term. So we're going to be using that later. Alright, so let's look at number 3. According to the rational root theorem, that's the P over Q concept, which is not a possible solution of this equation? I look at these factors, plus or minus 1 and 7. I look at these factors, 1 or 2. Which of these would not be a possible solution? We can get plus or minus 1, plus or minus 7, plus or minus 1/2, plus or minus 7/2. Which one could we not get? 2. That's the one that it could not be. All right. Find all the real zeros of this function. Well, I look to see if I can factor by grouping, and I cannot. I have to know some possible zeros. Those are going to be plus or minus 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Divided by 1 and 3. Now, I want to be somewhat realistic. It is extremely rare that I have solutions or zeros of 4, 48 over 1, or 48 over 3. It's very rare that it's this half that works. So we're going to start using synthetic division down here. You can usually just plug in 1 very easily. Would 3 plus 11, that's 14, minus 40, minus 132, plus 48, I don't know. I don't think that's going to give us 0, is it? No, that's not going to give us 0. So it can't be positive 1. I might want to check negative 1, but I don't know. I feel like that's not going to work. I'm going to go ahead, I'm going to try 2. So we plug in 2. So I get 6, that's 17, that's 34, that's negative 6, that's negative 12. That's not going to work, is it? Let's go on up to 3, because this is definitely not even close to working. I'm going to try 3. Let's see. Is 3 actually going to make it worse? This is what you have to go through, guys, on these types. You have to just keep trying to guess and check. I'm going to actually go to negative 3. I don't know if this one will work either, but we will see. So I'm going to have negative 9, that's 2, that's negative 6, that's negative 46. What's 46 times 3? 150 minus 12. Is that 132? That's 0. That's not going to work. Okay, so let's try positive 3. And if it really gets bad, here's what we can do, you guys. We can find one of these on our calculator, if it's a calculator part. I mean, really, I should sit here and just keep checking and checking, but for time's sake, I'll show you what else we can do. So I can go to my table, and I can just find a 0 here. Oh, there's one, negative 4. Okay, that might have taken me a while to find. So negative 4 is a 0. So what should my remainder be? 0. So I have 3, that's negative 12, that's negative 1, 4 is negative 36, 144, that's going to be 12. That's negative 48, and that's 0. Great. All right, so now this would be my constant, this would be my x, this is my x squared, and this is my x cubed. So now my equation is 3x cubed minus x squared minus 36x plus 12 equals 0. This can be solved by grouping now. I'm going to group these two and these two. Out of these two, I can take out an x squared, and I'm left with 3x minus 1. Out of these two, I can take out a negative 12, and I'm left with 3x minus 1. Out of this and this, I can factor out a 3x minus 1, and I'm left with x squared minus 12. All right, so now my solutions are, how many zeros am I supposed to have? 4, right? So one of my zeros was negative 4. What's going to make this equal 0? 1/3, right? And then I have x squared minus 12 equals 0. In solving that, I have x squared equals 12. Take the square root. X equals plus or minus 2 radical 3. Does that give me 4 zeros? Yes. All right. Irrational conjugates theorem. This theorem says if I have a plus radical b as a 0, then I also must have a minus radical b as a 0. They must be conjugates. This problem, it says write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and these are the zeros right here. This theorem says negative 5 is a solution by itself. But if 4 plus radical 2 is a solution, what else has to be a solution? Right. This is easy to write as a factor. The factor would have been x plus 5. But this one, these are two solutions. I'm going to find the sum and the product, like we did just a few minutes ago, because then I can get the equation quickly. What's the sum of these two if I add them? 8. If I multiply them, I'm going to have to FOIL. 4 times 4 is 16. Outers are negative 4 radical 2. Inners are positive 4 radical 2. Last times last is 2. Simplifying this, these are 0, and I get 14. So I have again x plus 5. Can you tell me what this would be then, using that sum product we talked about up here? It's going to go x squared what? Minus 8x, and then what? Plus 14. So this would be the form that I need, except it's not all multiplied out. So I have to multiply it out. Okay, combine your like terms, and I have to see what they want me to call it, g. So g of x is going to equal x cubed minus 3x squared minus 26x plus 70. That's going to be the function that has all of these zeros that I want. Okay? All right, one more thing here. Use the information in the graph to answer the questions. What are the real zeros? Real zeros are going to be right here where it crosses the axis. What's this one going to be? -6. Or no, it's not. Yes, it is. I take that back. It is. What's this one? 0. But this is going to have a multiplicity of what? Multiplicity of 2, right? Because it's a bounce. So now it says to write an equation of a cubic function. How many solutions should I have then? 3 solutions. 1, 2, 3. So in factored form, we love to see that, because that means I'm allowed to write this as just x squared times x plus 6. That's factored form. See, this one says a polynomial function. Polynomial means it's all multiplied out. But factored form means I'm allowed to just leave it like that. Okay? We're almost out of time, so I'm going to make another video just to show you this very last one that is a little bit complicated. All right?